A strange object has been discovered, orbiting Saturn, and we're going to intercept it. The image came in from the survey pipeline at 3:14 in the morning, and by 3:19 someone was already awake who should not have needed to be. A faint arc of light, tracked across 3 nights, curving in a way that did not belong to any known moonlet, any known captured asteroid, any known ring shepherd. It was orbiting Saturn. It was not on any list. Its brightness pattern refused to settle. Its spectrum came back wrong. Within weeks, an intercept was on the drawing board. Not proposed. Drafted. Agencies do not draft intercepts for objects they already understand. They draft intercepts for objects that are already saying something the models cannot hear. That is where this story begins, and where the calm version of it ends. The public version will be softer. The headlines will use unusual. The press releases will use opportunity. Every one of those words is technically correct. Every one of those words is also engineered to keep you from asking the next question. The detection did not come first, followed by years of debate, followed by a proposal. The detection came, and the mission concept followed almost immediately. That timeline is not how curiosity works. That timeline is how urgency works. Somewhere in the internal documents that will not be published in full, someone did the math on how long this object stays reachable, and the answer was short enough that the usual planning cycle collapsed. That collapse is the loudest thing in this whole story. Before we go further, tell me in the comments where you are watching from and what time it is for you. This kind of story travels best in the quiet hours, when the polite framing on the news does not sound quite as convincing. Here is my thesis, stated plainly. The object at Saturn is not the story. The story is what the intercept reveals about how little of the outer solar system we actually see, how quickly we can move when we are frightened, and how carefully we describe fear in public. By the end, you will understand why a single point of light around Saturn just rewrote what the phrase safe distance is allowed to mean. Because agencies do not commit billions of dollars and decades of careers to a footnote. So what does the hardware tell us that the words will not? The calm version of this story sounds like this. A new object was detected in the Saturn system. Its orbital parameters are being refined. A mission concept is under evaluation. International partners are being consulted. The science return would be significant. No threat to Earth. Interesting, but not important. Something for the specialists. Here is the problem with the calm version. It has been used before. It was used for Oumuamua in 2017, the first confirmed interstellar object, described in the earliest statements as a routine follow-up on an unusual trajectory. It was then, quietly, the subject of one of the most contentious scientific arguments of the last decade, with serious researchers publishing serious papers about non-gravitational acceleration that has never been fully explained. It was used for 2 I/Borisov in 2019, treated as routine, then found to have a chemical composition unlike anything in our own system. It was used again for 3 I/Atlas, detected in 2025, where the phrase "we will not be able to reach it" appeared in press coverage almost immediately, as if to preempt the obvious next thought. Every time the reassurance came first, and the strangeness came out slowly, in papers, in conferences, in the pauses between official statements. Now think about what is different this time. This object is not passing through, this object is at Saturn. It is in orbit, or in something that behaves enough like an orbit to justify the word. That means, unlike the interstellar visitors, this one is reachable. The reassurance "we will never see it up close" cannot be deployed. The agencies had to make a different choice. They had to decide whether to try. And they decided fast enough that the decision itself is now the most interesting data point in the story. If this object were as ordinary as the headlines suggest, no one would be building a spacecraft to chase it. Spacecraft cost billions. Spacecraft take years. Spacecraft eat careers. You do not commit that kind of resource to a footnote. The hardware, in every case, tells the truer story than the language does. And the hardware in this case is being drawn up on a compressed timeline that has no precedent for a target this far away. So what does the hardware tell us that the words will not? To answer that, we have to look at Saturn itself and at how much less of it we actually know than the pictures suggest. Saturn looks from a distance like the most orderly object in the solar system, a clean sphere, a flat, luminous ring system, a family of moons, each catalogued, each described. The rings have gaps with names, the moons have shepherds, and that image, that clean mechanical image, is where the trouble starts. Because Saturn is not a watch. Saturn is a barely balanced trap, and almost everything we think we know about its internal dynamics comes from one mission, one spacecraft, one 13-year window, followed by a deliberate destruction in 2017. That mission was Cassini. It arrived at Saturn in 2004 and ended in 2017, when its controllers steered it into the planet's upper atmosphere to protect the moons from contamination. 13 years. Hold that number. Now compare it to the age of the system it was observing. Saturn is roughly 4.5 billion years old. If you scaled Cassini's mission down to a human lifetime, it would be less than 1 second. We took a 1-second glance at a system older than the continents, and we built our confidence in its stability out of that glance. Here is the part that should bother you. The Saturnian system is not a closed clockwork. It is a place where things arrive, stay for a while, and leave. And we have almost no idea how often. If the system routinely hides objects from us, and routinely catches new ones we cannot see coming, then the real question is not what this particular object is. The real question is what else has already arrived without us noticing. To understand why we cannot see what we cannot see, forget the mental picture of telescopes watching the sky. What we actually have is a small number of survey systems, each with narrow specialties, each covering a fraction of the sky on a schedule dictated by weather, funding, and priorities set years in advance. Everything outside that coverage is not observed. It is not that we looked and saw nothing. It is that we did not look at all. Every telescope has a limiting magnitude, a threshold below which objects are invisible in a single exposure. The best current wide-field surveys hit their limits around magnitude 22 to 24. Translate that, an object the size of a small mountain at Saturn's distance sitting in shadow, reflecting almost no sunlight, is below that threshold. It is there, it is real, it is moving, and it is invisible. Not because the machines are broken, because the physics of light does not allow enough photons to reach the sensor in the time the sensor is exposed. Now, add the cadence problem. Surveys revisit the same patch of sky every few nights, sometimes every few weeks. An object moving slowly in an inclined orbit that takes it out of the ecliptic can pass through several observation windows without ever appearing in 2 consecutive frames the way the detection pipeline requires. The pipelines are designed to catch things that behave like standard solar system objects. Something unusual gets filtered out as noise. The pipeline does its job. The object slips through. The historical record is uncomfortable. Chiron, an object roughly 200 kilometers across, orbiting between Saturn and Uranus, was not discovered until 1977. 200 kilometers, a small country, undetected until 47 years ago. Phoebe, one of Saturn's larger irregular moons, was discovered in 1899, but its true nature as a captured object was not understood until Cassini flew past in 2004. More than a century between discovery and comprehension. These are not obscure specks, these are worlds. They sat, technically visible, unread by us, for generations. I am not saying astronomers are bad at their jobs. I am saying the sky is bigger than the budget. Every discovery is a signal that something crossed a threshold. Every non-discovery is silence, and silence is not evidence of emptiness. If our best telescopes miss this class of object routinely, then the Intercept mission is not chasing a curiosity. It is chasing the first specimen of a category we have been failing to see for decades. Now let me tell you what we are going to intercept it actually costs. The phrase gets thrown around as if it were a routine matter of pointing a rocket at Saturn and pressing the button. It is not. Cassini launched in October 1997 and arrived at Saturn in July 2004. 6 years and 9 months. It did not take a straight line. It used gravity assist from Venus, Venus again, Earth and Jupiter, each carefully aligned with where the planets happened to be in the late 1990s. If the launch had slipped by a few months, the entire trajectory would have needed a redraw, sometimes with penalties measured in years of additional flight time. Voyager did it faster in 3 to 4 years, but they were riding a once in 176 year planetary alignment, and they were flybys. They did not stop. An intercept has to arrive with enough remaining velocity to actually reach the object, match its orbit closely enough to observe it, and stay long enough to learn something. That requires a fundamentally different engine and a fundamentally different fuel load. Here the physics gets ugly. The rocket equation says fuel requirements grow exponentially with velocity change, not linearly, exponentially. Every extra kilogram of fuel has to be lifted along with all the fuel below it. The whole stack compounds against itself until the numbers become absurd. This is why Cassini spent 7 years threading planetary flybys. Nothing we currently build can do it faster on brute force alone. Now compare timelines. Europa Clipper was approved in 2015 and launched in 2024. Dragonfly, approved in 2019, targets a 2028 launch. JUICE, approved in 2012, launched in 2023. These are the standard timelines. Roughly 9 to 11 years from approval to launch. Add 5 to 7 years in transit. A mission approved today on standard timelines arrives at Saturn in the late 2030s or early 2040s. That is the schedule the object does not care about. If it is a temporarily captured body, its window may close before then. The Intercept could arrive to study a piece of empty sky where something used to be, and the mission would still be considered a success by the people who approved it, because the alternative was not trying. And that assumes the machine survives what Saturn does to machines. Saturn is not a place. Saturn is an environment, and the environment does not welcome visitors. It erases them slowly, over years through radiation, cold, distance, and isolation that no laboratory on Earth can fully simulate. Start with the radiation. Saturn has a magnetosphere, and inside it are belts of charged particles trapped by the planet's magnetic field. Not as brutal as Jupiter's, but not gentle. Every hour a spacecraft spends inside those belts is an hour of accumulated damage to its electronics, sensors, and command systems. Radiation does not kill a spacecraft immediately. It degrades it. It flips bits in memory. It scars sensors. Cassini was designed to tolerate a specific total dose across its mission lifetime, and by the end, it was operating in a state its designers would have called marginal at the beginning. Translate that. A human being exposed to the radiation near Saturn's inner rings without heavy shielding would face lethal doses within weeks, not because Saturn is trying to kill anyone, because the physics of trapped charged particles does not care what it hits. Spacecraft die from the same physics, just slower. Now add the cold. At Saturn's distance, solar flux is about 1% of what Earth receives, 1%. Solar panels are largely useless. Every watt has to come from radioisotope thermoelectric generators, which produce electricity from decaying plutonium-238. Cassini carried 3 of them. They provided a few hundred watts, declining over time. Less than a small kitchen appliance. That is what powered a spacecraft the size of a school bus, more than 1 billion kilometers from home for 13 years. Now, add the distance itself. Saturn is between roughly 1.2 and 1.6 billion kilometers away. Light takes 68 to 90 minutes to cross that gap one way. A round-trip conversation takes 2 to 3 hours minimum. No one is flying the Intercept in real time. The spacecraft has to make almost every important decision on its own, using software written months or years earlier. If something unexpected happens by the time Earth reacts, the spacecraft has already committed. The correction, when it arrives, is a correction to a situation that no longer exists. The hardware problem is solvable. The economics of solving it in time is where the story turns political. There is a phrase used inside the planetary science community, quietly. The phrase is the collision of timescales. The objects we study operate on geological or astronomical timescales, measured in millions or billions of years. The institutions that study them operate on fiscal timescales, measured in single years and budget cycles. Most of the time, the mismatch is uncomfortable, but survivable. And then, occasionally, an object appears that does not respect the mismatch. It shows up with its own clock, and that clock is shorter than the budget cycle. Everything quietly deferred, understaffed, and undersupplied comes into sudden focus. The Intercept mission is that kind of object. Flagship outer planet missions cost $2 to $5 billion, sometimes more. Cassini cost roughly $3.5 billion, spread across 2 decades. Europa Clipper is running around $5 billion. These are not numbers a single agency can produce on demand. They require multi-year appropriations, sustained across changes in political leadership. An object that appears between decadal survey cycles and demands attention before the next one has to fight for funding in a system not designed to be interrupted. Add the workforce problem. The engineers who built and operated a spacecraft that survived at Saturn are few, and getting fewer. Cassini's launch team began work in the late 1980s. Many of them have retired. Institutional knowledge lives in people, and people age out. Documentation is thin compensation for the person who remembers. Why a specific bolt was chosen after a specific test failed in 1994. Add the parts problem. RTGs run on plutonium-238, which has to be manufactured in specialized facilities. US production, restarted in the 2000s after a decades-long pause, is measured in hundreds of grams per year. Every mission needing an RTG has to reserve its plutonium years in advance. Europa Clipper, Dragonfly, and future Mars sample return have already claimed their allocations. Adding a Saturn intercept means taking plutonium from a mission that already has it, or accelerating production the facilities may not sustain. None of this is corruption, none of it is incompetence. This is the collision of geological timescales with fiscal year timescales, and doing the best you can inside constrained systems does not make the intercept feasible on the schedule the physics demands. It makes it a bet against your own institutional speed. And this is exactly why the official language stays careful. Because the alternative is admitting what the mission implies. Listen to the language now. Every phrase used in an official statement about an anomalous, astronomical object is chosen by people whose job is to describe reality in a way that does not create problems the underlying reality has not yet forced them to solve. The result is a vocabulary that is technically accurate and emotionally engineered. Start with the word unusual. When an agency describes an object as unusual, they are telling you something specific and something vague at the same time. Specific because it means the object does not fit standard categories. Vague because it does not tell you which category, or by how much, or in which direction. Compare it to the word researchers might use privately, which is unexplained. Unexplained is a heavier word. Unexplained says the models do not work. Unusual just says the object is not average. Then the phrase, consistent with. When a statement says an object's properties are consistent with a known class, it is not saying the object is a member of that class. It is saying the properties do not rule out membership. A large captured asteroid can be consistent with a comet if you squint. Consistent with is a phrase deployed most heavily when no one is yet sure. Then no threat. Technically true. Emotionally powerful. An object orbiting Saturn poses no immediate threat to Earth. What the phrase does not address is whether the object is a threat to our assumptions about what is out there, or to our confidence in our detection systems, or to the model of the outer solar system we have been operating on for decades. Those threats are real, and they are precisely what the phrase is designed to make you not think about. Look at the history. Oumuamua was initially described as unusual with no immediate concern. Within months, researchers were publishing papers about its non-gravitational acceleration and its bizarre shape. One prominent Harvard astronomer argued the object could not be ruled out as an artifact. The point is not whether he was right. The point is that the initial vocabulary did not prepare the public for the debate that followed. The vocabulary flattened the surprise. The debate then had to reintroduce it. None of this is lying. All of it is institutional grammar. And once you learn to read it, the calm on the surface starts to look like exactly what it is. A careful surface above a much less settled conversation happening underneath. The Intercept mission is not really about the object. Hold on to that sentence. The Intercept is about whether our civilization can respond to a specific class of surprise at all, and the object at Saturn is the first serious test case in an era where these surprises will arrive more often. Consider the timeline. Oumuamua, October 2017. 2I/Borisov, August 2019. 3I/Atlas, 2025. 3 confirmed interstellar objects in less than a decade, after 0 in all of previous human history. Not because interstellar objects suddenly started arriving, because our surveys finally became sensitive enough to notice them. If we are finding them at roughly 1 every 3 to 4 years, and if our surveys are catching only the largest and brightest, then the true population passing through our system at any moment is not 3. It is thousands or tens of thousands. The Vera C. Rubin Observatory, when fully operational, is projected to detect dozens per year within a decade of full operation. That is not a small change. That is a change in category. We are transitioning from a solar system we thought was mostly closed to one we can now recognize as porous, constantly traversed, and full of objects we have no lineage on. Now let me be honest about planetary defense at Saturn's distance. Planetary defense concerns objects that could impact Earth. Its response component means deflection, and deflection has been demonstrated exactly once, by DART in 2022, on a small asteroid moon at close range. At Saturn's distance, no deflection is possible, no evacuation is possible. There is only observation. So when someone says the Intercept is about planetary defense, they mean that we need to know, before something like this appears closer, how these objects behave and how our detection systems perform against them. The intercept is a rehearsal for the day something anomalous is found much closer, on a much shorter clock, when the response has to be actual defense. Compare it to Apollo. Apollo was not really about reaching the moon. It was about proving a civilization could commit to a difficult goal and deliver it on schedule. The intercept has the same structure, quieter and with worse odds. If we can, then when the next object appears closer, we have a template. If we cannot, we build the template from scratch. Under pressure, the intercept mission is not yet under. That is why the intercept exists. That is why it is being drafted with urgency the standard planning cycle does not accommodate. That is why the public language is careful, because the real argument is not about one object at Saturn. The real argument is about whether the outer solar system surprise response system is capable of surprise response at all. And the honest answer right now, based on budget cycles, workforce, parts supply and launch cadence, is barely. The intercept is the stress test on that answer. Which brings us back to the object itself, and to the one question that the mission is really designed to answer. That question is not, what is this object? That question, honestly, could be answered from Earth over enough time. The question is whether the object is the first, or whether it is one of many. If it is the first, it is a curiosity. If it is one of many, then everything about how we think of the outer solar system has to change. Let me end where honest endings should end, not with a comforting summary, not with a final scare, with a clear statement of what we now know and what we now have to carry. What we know is that an object was detected orbiting Saturn that does not fit any category our current models comfortably accommodate. An intercept is being drafted with a speed only justified by internal urgency the public conversation does not yet reflect. Our surveys, our budgets, our workforce, our parts supply, and our public language are all currently misaligned with the timescale the object itself is operating on. And this misalignment did not begin with this object. It began decades ago. This object is simply the first time the misalignment has been forced into visibility. What we have to carry is heavier. The next time an anomalous object is detected, closer to Earth on a shorter clock, the systems we would rely on are the same systems currently straining to accommodate this one intercept. The phrase "no threat" is not a promise about the future. It is a description of the present, based on the information we currently have, using the categories we currently recognize. When the categories change, the phrase changes too, and the categories are changing faster than the language is being updated. Return with me one last time to the beginning. To the arc of light on 3 nights of survey data. To the analyst who saw it and did not sleep well after. To the concept meeting that followed, to the drafts that circulated, to the engineers being called back into rooms they thought they had retired from. All of it from that arc of light. All of it because a single detection crossed a threshold that our comfortable framing was not built to handle. I'm not asking you to be afraid. Fear is the wrong response. Fear is what the careful language was designed to prevent, and preventing fear is not, in itself, wrong. The right response is clarity. Clarity is knowing what has been softened and being able to hear it anyway. Clarity is understanding that no immediate threat has immediate, doing all the work in that sentence. The strange object at Saturn is not the story. The strange object at Saturn is the moment we were forced to notice how much we do not yet see. The story is what we do next, and whether the sky, from now on, gets the seriousness it has always deserved. Somewhere, tonight, in a survey pipeline running quietly on a mountain we will never visit, the next detection is already being processed. It has not yet crossed the threshold, but it will.